In this tutorial, we are going to talk about trigonometry. Basically, what is a use, what are the applications, and how exactly we define the relations between the angles and the ratio of the sides of a triangle. Okay, so take a look at the name itself. It has three components to it: tri, gon, and metri. Metri means measurement, gon means side, and tri is three. That means it is linked to the measurement of the sides of a triangle. And of course, when you're talking about triangle, you're also going to talk about angles, right? So talking about the applications, take a look at this example number 1. We have that we want to measure the height of this tall building, right? Which is rather difficult to do. So what you do is, instead of measuring the height, we measure that what if we could define a point which is at certain distance L from the base, and from this point, if we could measure the angle of viewing from this point which is at the base to the point at the rooftop, which is not hard to do. There are many instruments that could do it. So once you know this angle and once you know the position of this viewing point from the base, we could measure the height. This is what trigonometry helps us in doing. And likewise, you could utilize the same principles in construction industry, where we want to measure at what angle should we construct a roof if we are given the run or the rise of that roof with respect to certain positions. Okay, so these are some of the applications, and likewise there could be countless number of examples we could quote, whether the application in space or whether the application in marine industries or oceanography or measuring the distances which are very far and hard to measure. Using the principles of trigonometry, it has made it possible that we could accomplish all of those objectives. Okay, now how do you do it? That's exactly what we are going to look next. So one of the first thing we want to understand is that we always begin our discussion of trigonometry principles with a right angle triangle. Let's say there is a right angle triangle ABC, and we know that the side AC is known as the hypotenuse, right? This is one of the commonly used word in a right angle triangle. Okay, and let's define our angle theta. This is the angle that hypotenuse makes with respect to the base BC. Okay, now there is a specific terminology that we'll be using. The distance AC is called hypotenuse, right? The base BC is called adjacent side. Adjacent means this is the side which is immediate next to your defined angle theta. Okay, and whichever is the third side remaining is the side which is opposite to the angle theta is known as opposite, of course, correct? So we could define the short names for this. Opposite is called as O, adjacent is called as A, and hypotenuse could be defined as H. Okay, now let's talk about the relation between the angles and the sides. Okay, now we know that angle is measured in degrees, so it is theta degree, right? But the distances of all of these sides are measured in either in centimeters or inches, right? Or in meters, whatever unit we define, right? Now, these two units of measures are not relatable. You could not relate a degree with the centimeters or inches, right? So that is why we need a unitless quantity so that we could find the relation between these two things. Now, that unitless quantity could be defined in three ways. We could identify a measure what is known as sine of theta or cosine of theta. And then finally we have tangent of theta. It is, in short, it is written as tan theta, right? Now, sine theta, it is simply a ratio of two sides which is opposite to hypotenuse, or you could write it like this, O over H. Now you see, O over H, these are the two units in distances, but once you find the ratio, it becomes unitless. And likewise, the moment you find the value sine theta, it becomes a unitless quantity. So now you could relate the angle which is in degrees with the ratio of two distances, and that's how you find the usefulness of trigonometry. Okay, likewise, you will define that the cosine value of theta, or simply known as cos theta, is known as adjacent over hypotenuse. Okay, and tan theta or tangent theta is simply a ratio of opposite to adjacent. Okay, these are the three most important fundamentals you want to remember. That how do you create a linkage of the ratio of the sides with either the sine or cosine or tangent value of theta. Okay, so at this moment I would like to define another set of measurements. So that is simply finding the inverse of these values, meaning what will be called that inverse of sine theta. I would say that there is a term, it is called cosec of theta. This means that cosec value of theta times the sine value of theta is equal to 1. Likewise, I have an inverse of cosine of theta, and that is known as the sec theta, right? It might sound confusing, but this is how you are going to remember that inverse of cos is sec. This also means that when you multiply these two quantities, sec of theta times cos of theta, it is also equal to 1. And finally, you have another term in which we have 1 over tangent of theta, or finding the inverse of tangent of theta is known as cot theta, right? Or cot theta times tangent theta will be equal to 1. So this is how you find the one set of values, sine, cosine and tangent, and this is how you find the inverse of those values. Rest all is very simple. It is not complicated at all. It is simply finding a ratio of any two sides, assigning them to one of these values, and based on that you wanted to solve whatever you could solve, right? Now let us go take a look at how we will utilize these 6 factors into the calculations of various angles. Okay, so let's take a look at our example. So in this problem, we have been given that if cosine of theta is 4 over 5 and theta is an acute angle, what is the value of this expression? Sine theta plus 1 over tan theta. Okay, so take a look at this diagram. We say that I have a triangle A, B and C. Okay, in this triangle I'm defining this is my angle theta. So based on that value of theta, this will be opposite. Of course, this is hypotenuse and this will be adjacent. Correct? Now we are given cosine of theta that is equal to 4 over 5, and we know that the cosine of theta is a ratio of adjacent to the hypotenuse, right? Now in this case, we have these two sides, we have their ratio, but we don't have their exact value. So in that case, if I make a simple assumption that let's say h is equal to 5x, right? In that case, you could say that a is equal to 4x, because the ratio of these two sides is 4x to 5x, and that gives you 4 over 5, which is exactly what we have, right? And by the way of Pythagorean principle, I can say that h square is equal to a square plus o square. If I simply plug in what I know, then I find that h square, which is 5x whole square, is equal to a square is 4x whole square plus o square. At this moment, o is unknown to us. And by the way of this simple mathematics, you can say that o square is equal to 5x whole square minus 4x whole square. And when you solve this, you will find that this will be equal to 9x square. Or when you take the square root on both sides, you will say that o is equal to 3x. Okay, so now we have a relative value of each one of those in terms of x. We have o as 3x, we have a as 4x, and we have hypotenuse as 5x. So based on that, can you find the value of sine theta? Of course we could. We could simply find it is a ratio of opposite to hypotenuse, and this is opposite is 3x, hypotenuse is 5x, or it is 3 over 5, right? That's one. And likewise, I will say that the value of tangent theta is equal to opposite to the adjacent, or in other words, it is 3x divided by 4x, which is 3 by 4. Now we have everything that we need. We have the tangent value, the sine value. We can simply plug these values in this expression and we obtain our desired results. So that will be sine theta will be 3 over 5 plus 1 over tangent theta. Tangent theta is 3 over 4. So it is 3 over 4. So this is 3 over 5 plus. So when you solve all of this expression, you will find that the denominator becomes 15 and the numerator is 29. So our result in this case, the value of this expression sine theta plus 1 over tan theta is equal to 29 over 15, right? So the idea in this tutorial is not necessarily to go over this mathematics. The idea is that how do you define the relation between various sides of a triangle and create a linkage of those sides with the angle, the one angle that we could define. So with that, we will take a pause here, and in our next tutorial, we will dig a little bit more into the details of what if that angle is 30 degree or 45 degree. Are there any special angles? Based on those values of special angles, we will talk about how to obtain the ratio of the sine or cosine or the tangent values.